Hi there, Jim here. Today we are going to have a look at this FNIRSI. I hope that's how it's pronounced. FNIRSI. I've always called it FNIRSI. Um, Intelligent Color Screen Multimeter. That's what it says it is. This is a unit that I obtained through the Amazon Vine program. So let's unbox the unit and then we'll put it through its paces. Okay. Some good plastic overwrap. Okay. I should mention FNIRSI is one of my sort of preferred manufacturers out of China. I'm generally pretty impressed with the items they produce. So if we look at this, we can see that we've got a quality control little piece of paper. Hope that means something. We've got a manual here, and the manual is in several languages. So I think English is something like, I don't know, maybe 10 pages. And then we have in here the unit itself, and it's in this wonderful white stuff that wants to rip. Okay, and that looks pretty nice. It's got a hanging spot. It's got some rubber molding here that'll hold the probes, and it's got a stand-up bail here, or a stand, so that'll hold it up. You can see that it is color coordinated with my soldering mat. Fantastic. Always important. And probably one of the things that we'll need to do before we get too far into actually reviewing this is charging it. So it looks like it uses a rechargeable battery and it's charged with USB-C, so we'll have a look at that. And then if we delve deeper into the box, we've got the dreaded USB-A to USB cord, which is meant for charging. I'm not too thrilled about that, but it is what it is. And a pair of probes. The rest of the box is empty. So that's the whole thing. Okay. And, well, the probes, it's unlikely that these probes are silicone wires. No, these are PVC wires. If these were silicone wires, they'd be flopping around like mad. They are, I don't know if we'll be able to read them. 42C, PVC, definitely PVC. Won't focus on that. PVC. But they are rated for 1,000 volts. So, and the ends here are firmly attached, so they're not sort of the replaceable ends. And we've got some very sharp tips there on the probes, and those tips are permanent, so there's really no way to swap those out either. So these are the probes and the tips you get, and if you're good with that, super. If not, you'll need to get yourself another set of probes and tips. So that's good to know. So let's, I guess, set about charging this. So charging is accomplished by plugging the USB-C cable into the port up here, and it would help to make sure that it's powered on, and you can see that that turns on a little indicator light there, which is hard to tell here. Studio light is so bright, and so that light is going to stay on while it's charging, and I imagine it will turn green once it's charged. One of the things that I was able to confirm is that this will also charge with a power delivery capable USB-C cord, so you don't have to use only these USB-A to USB-C cords, which I'm generally not fond of because of what they indicate about the other end of the connection here. But I did try this out with a power delivery source, and it was able to actually, it lit up the button there. Okay. So we'll let that charge for a couple of minutes, or as long as it takes, and then we'll be back and work on the next phase. All right, and so a little while later, we can see that the light there has turned green. Let's locate that a little better. I'll zoom in a little more. There we go. So you can see the lights turn green, so that means it's fully charged. Unplug that. Okay, and now it's ready to start using. Plug that in. Plug the red line in. Okay, and so now we're set up to measure, as we can tell from the labeling. We can measure voltage, we can measure resistance, and I think that's capacitance, and then underneath here, maybe you can see we can do diode check, continuity, and temperature, although I'm not sure. There were no temperature probes in the package. Well, anyways, without further ado, let's turn it on and see what we get. So, English. That's kind of neat. Okay, so now it's set up in auto, and I've taken the insulators off of the probes. And so the first thing I always do with a multimeter, I mean, doesn't everybody do this the first thing? Continuity. Okay, well, not very fast. Okay, so if you hold the probes together for a while, you'll get the familiar beep of continuity. But one of the things I like to do, and if you've seen some of my other multimeter reviews, I like to kind of tap the probes together, and you can see that while I'm tapping, the display is changing, but it's not really giving me the wonderful continuity beep, because of course that quick tap is not enough time to really be certain there's continuity, right? Not terribly slow, but I like to tap at a rate like that, and I always demonstrate. And you know, sometimes you might have a noisy circuit that you're testing, or you might have a contact that's not working all that well. And so I think it's beneficial to have a very responsive continuity check. I always bring out the big gun here as the comparison for all of these multimeter videos. So I've got a fluke here. Okay, I know fluke, it's the gold standard. We'll put that onto continuity. Okay, now watch. Okay. Okay, the fluke doesn't miss a beat, although I think the ones where it missed, I missed with making contact. Okay, so the fluke's super fast on continuity. I know that's a tough bar to meet, and it's not as though the FNIRSI is totally fallen down on the job here. You can see it is doing something, it's noticing something, but it's not noticing enough for continuity. Now, one of the things is that right now it's in auto mode. What if we put it into dedicated continuity mode? Since, you're going to say I'm not really being very fair about all of that. There we go. Diode check and continuity seem to be the same thing. So if you are really worried about the responsiveness, still not quite as responsive as the fluke, but a lot better if you put it into the dedicated diode check continuity mode. A bit faster in terms of responsiveness. And that's, of course, pretty common with a lot of these new multimeters that are, let's say super automatic, because aside from determining what the value is that they're reading, they have to determine what they're reading. Are they reading a voltage? Are they reading resistance? Is it supposed to be continuity? What's going on? And they have to sort of do a little bit of analysis, which takes a little bit of time to figure out exactly what they're measuring. So that can be handy if you're doing something where to know if you're doing something where the your time concern is there, that you can switch them into this specifically into the mode for what you're trying to work with in order to get better response. Okay, so that's continuity. Like I say, continuity is always my favorite first test. So now let's look at a couple of other things. I'll just leave the fluke there because we'll want to use it for some comparisons. Okay, back to full auto. I've got battery there from my favorite retailer, Costco. Sorry. So let's just do a little test of the battery here. Oops, I just saw that. You can't see where I'm when I'm touching the probe, so let's sort of adjust the frame here a little bit so you can see the battery. See what okay, so now you can see. So it's in full auto mode, not touching yet. So that's pretty quick. So that's full auto. And the battery measurement, 1.499. We're going to use the fluke for comparison. Let me just prop the fluke up on a little bit of a stand so you don't get all the glare there. Okay, so for comparison, the fluke. Hello? Fluke, are we connected? We are. Are these the right probes? They are. They're plugged in. Oh, it helps. See, that's where full auto comes in handy. I was not on voltage. Okay, so DC volts. And now we'll connect. 1499. 1499. So performance is about the same. And you got to admit, the accuracy is identical to the fluke, which is fantastic. Okay, and so we see that the DC voltage there works really well. Let's give AC voltage a try. So I've got for AC voltage, I've got a power cord that I drag into the frame here. Okay, so y'all probably have dozens of these lying around. So remember, when dealing with AC current or AC power, you need to be very careful. So make sure you know what you're doing whenever you're dealing with AC. So now I'm going to put one probe in there. I'm going to put the other probe, 121.8. That's pretty quick. 121.8. Once again, pretty quick. Okay, we'll do the same thing with the fluke. remembering to set the right mode first. One probe in there. 122.0. Okay. 121, 122.2. Okay. Go back to the FNIRSI. 121.8. So maybe measuring a little bit high on the AC voltage, but given that AC voltage tends to vary during the day by up to 1 or 2 volts typically, that's really not the end of the world. 121.8. Okay, so the fluke was giving us 121.2. So that's, I think that's pretty decent for AC voltage for anything that we're going to really care all that much about. And of course, this is all being done in auto mode, and that was pretty responsive. Now let's take this out of the way. So we've done AC voltage, DC voltage. Now let's look at, oops, don't need that battery. Let's look at resistance. Okay, so I've got over here, if you can see that, that's a 47 k ohm resistor, and this came out of a vacuum cleaner, I think. Anyhow, so we'll just get the probes onto that. One side, the other side, 46.39. Trying to test the responsiveness. Okay, so it figures out its ohms, figures out it's 46.39, 46.4. Okay, pretty quick. We'll do a similar test here with the fluke. Okay. .39, 46.4. Okay, so the fluke and the FNIRSI, in terms of measurements, they're pretty much agreeing completely. And performance is pretty good. So the performance so far has been fantastic. Okay, so if you want to measure capacitance, we have to put it into capacitance mode. Their capacitor is a little more stylized than I prefer, but it works. It's good enough. A little while. 218. Okay. Remember that in order to figure out the capacitance, it's got to charge the unit up a little bit. So let's try that again. So it takes a while, but eventually it does figure out the capacitance. Okay. So I would not say it's the fastest thing figuring out the capacitance. We'll do it a third time. It takes, okay, almost 220. It takes long enough that it makes me wonder that I'm not getting good contact. But we can do the same thing here with the fluke. Okay. Get the fluke probes going here. And you will see that it is possible to kind of measure a little bit better. 221, right? So 220. So quite a bit faster than what's going on with the FNIRSI on capacitance. And I've got a feeling that we're going to see a similar kind of behavior out of diode check. So if we put this into diode check, which is diode / continuity, and what this should indicate to us is the bias voltage, a few hundred millivolts. So if we put that on the negative side, this on the positive side, okay, that's pretty responsive. Okay, 222 millivolts. Because I know you want me to compare, We'll get the fluke into diode check mode as well. And like I said, the performance on the FNIRSI was pretty good, so I don't think we're going to see great improvement in performance here. So with the fluke, okay, 213 millivolts, 214 millivolts. So about the same. You get a little bit of a beep out of the fluke when it sees everything going all right. So for diode check, I would say FNIRSI works pretty well, although you have to be in diode check mode to make sure that it's working. So what have we covered off so far? We've done AC and DC voltage. We've done resistance, capacitance, diode check, continuity, all the basics. So there are a couple of other things that we need to go through. So first off, let me get a AC voltage line. Okay. Now, one of the things is not all of these modes work in auto. So some of these things, you've got to actually push the unit into a specific mode. And so for non-contact voltage and for hertz and temperature, okay, so it's saying it's 16, so there must be a temperature sensor inside the unit. It is a little bit cool here in the studio. So I think 16 is probably a reasonable measurement. Okay, hertz. So if we put this in, we're probably going to get, let's just put this somewhere that's going to be a little safer to deal with. Okay, so put one line in there. Okay, so I only need the one probe in, 60 hertz. That's kind of what I would expect out of the AC mains. Takes a while to reset back to 0, but that's fine. Okay, then we have what looks like sort of radar mode. Okay, and this might be the live detection. Okay, now it said something on the display. Let's see if I can make out. Okay, well, okay, that's not actually any English characters, but that tells me which line is live. So that's the live side of the plug. Excellent. And this may be non-contact. Okay, maybe this is for, okay. Okay, back to temperature. So we've got temperature, frequency. I would expect that with these symbols here, that's meant to be the non-contact voltage testing. Okay, so if you get it close to an AC power source, it can sense what's going on. But I don't know, it's not, I don't consider that to be really sensitive. I'm holding that right up against the power cord. Okay. So I would generally expect non-contact voltage testing to be a little more sensitive. Like if we do the fluke is kind of non-contact happy, if you will, but you can see that, well, sorry, if I bring the power towards the fluke, it doesn't really need to be very close. Okay, that beep is going to get annoying. So the non-contact voltage testing is not anything to write home about. I would really expect it to be a little more sensitive than that, especially if I were working in an electrical wiring box doing some AC work. So that symbol, I guess, means it's doing non-contact voltage sensing. And I think this is meant to detect live wire, since you just see the wire. And, well, that probe's not going to do anything. We'll take this probe. That's not the live hot side, but that is the live hot side. And so that tells us that's the hot side. So that works the way we expect it to. And once you learn how to read the symbols, everything is good there. And then, once again, back to temperature measurement, which will tell us what the temperature is here, but this doesn't come with a pair of temperature probes. And I don't think me touching the probes is going to make any difference whatsoever. Setting up to measure current, I've got a little circuit here. This circuit, it's just got a little resistor there, an LED. If I turn the power on, I'm feeding 3.3 volts into this circuit. This is coming off my bench supply. And my bench supply is telling me that I'm using about 8 milliamps. Okay, so now let's see. To do the measurement, I'm going to replace this red wire in the circuit. I'm going to put the meter in line in series. So first thing I have to do is I have to pull this out of the voltage there and plug it into the milliamps. Okay, and then what I'm going to do is I'm going to pull this out, and so that LED is going to go out. And then what I'm going to do is I'm going to hook these up. Okay, now the bench supply without that circuit, there's some, you can see there's a breadboard power supply module here. So it's doing about 4 milliamps right now. And when I connect this, and you can see that LED lights up again. Oops, I need to go into milliamp mode here. So, okay, that lights up again. And 39, 4,000. And if you can see it at the end, it says microamps. So it's quite sensitive. That's about 4 milliamps. So I've got 4 milliamps in the current here, 4 milliamps being used in the breadboard power supply module. So I would say that reading is pretty accurate. If needed, for comparison, since that's what we generally do, we'll go over here to the fluke and put this into amp mode. You can see that there. A little bit of glare on the screen. And 4, although in a different way, that's 4 milliamps. So all in all, well, it's not holding the measurement, but that was showing about 4 milliamps. Not only that, but it got down into the microamps as well, something which the fluke doesn't really have the ability to do because it's a fixed display and it doesn't range down that far into the microamp range. That takes us to the end of part 1 of this review of the FNIRSI DMT-99. And in part 1 of this review, we've seen a couple of things. We've gone through all of the basic features being things like, voltage, ohms, resistance, capacitance, diode check, continuity, milliamps, non-contact voltage, things like that. And for the most part, we've seen that these capabilities work very well. The capacitance turned out to be a little slow. I mean, it was accurate, but a little slow. The non-contact voltage was disappointingly unsensitive or insensitive, although, as I might have mentioned at the time, generally for non-contact voltage, a multimeter might not be the first thing that I would use for non-contact voltage. I'd use probably more of a pen type non-contact voltage sensor. So those are fine. Continuity, as long as you're in the dedicated continuity mode, it's fine. If not, in auto mode, it's a little slow. Um, One of the things that this does, although it's not sort of kind of clear here, but this will measure down into the microamps. And so that's something the Fluke doesn't even do that. And so that's an advantage that this has over something like the more expensive Fluke. Um, and even though this has temperature sensing, it doesn't have the probe included in the package to do the temperature sensing. So it's a little difficult to comment on that. The second part of this video is going to go into the other features in this multimeter, and there are a lot of other features in this multimeter, but those are the ones that I consider to be the advanced features. So things like the relative measurement features, and then there's a whole bunch of features that are sort of hidden behind the implication of the menu. Okay, so once we get into the menus for configuration, there are all kinds of other features that are available to us. And so in part 2 of the review of this unit, we'll go into, or I'll go into, those features, and there are quite a lot of them. This is a very kind of feature-packed unit. Anyhow, that was it for the basic features. I hope that that's been informative for you. Thanks for watching, and please do subscribe to my channel.